You ever wonder if the AI that writes your emails could learn a thing or two from the AI that spots faces in your photos? Well, let's dive into that, because a really fascinating new research paper suggests exactly that. We're going to break down something called LLM JPA. It's a new method that could totally change how we train large language models, all by borrowing a clever trick from the world of computer vision.
So here's our game plan. First, we'll look at the two very different ways AI learns right now. Then we'll unpack this cool trick from vision models and see how researchers got it to work for language. After that, we'll dig into the test results, and they're pretty impressive. We'll also explore some of the deeper benefits. And finally, we'll talk about what this all means for the future of AI.
All right, so to really get what's so new here, you first have to understand that there's this big split in how we train AI. There are basically two major schools of thought, and they have really different approaches.
Think of it like this. On one side, you've got your standard LLM training. That's kind of like learning to complete a sentence. The AI gets really good at predicting the next word to fill in a blank. But on the other side, you have the JEPA method from computer vision, which is more like learning to understand the idea of the sentence. Instead of just filling in the blank, it learns the underlying concept of an object from different angles.
Okay, so let's zoom in on that second approach. The one from computer vision that's been such a game changer over there. So what in the world is a Joint Embedding Predictive Architecture, or JEPA? Well, at its core, it's a model that learns by predicting abstract ideas, what the researchers call representations, instead of just raw data. By not having to recreate an image pixel by pixel, it learns way more efficiently. This lets the model focus on what's actually important instead of getting lost in all the tiny, irrelevant details.
Here's a great way to wrap your head around it. Imagine an AI sees a photo of a building at sunrise. It doesn't memorize the photo, no. Instead, it creates this high-level, abstract concept of this building. Then it's asked to predict the abstract idea of that same building, but this time at noon. It's not trying to guess the new shadows or the lighting, just the core concept of the building. And by comparing its prediction to the real idea of the noon photo, it gets better and better at understanding the building itself, no matter what time of day it is.
And this brings us to the million-dollar question that the researchers behind this paper were asking. If this kind of abstract learning is so powerful for images, could we possibly make it work for language?
And the big aha moment was realizing that language already has these different views built right in. The researchers figured out that, for instance, a bug report written in plain English and the piece of code that actually fixes that bug, well, they're just two different ways of looking at the exact same problem. They're two views of the same underlying concept.
So they came up with a new training formula, LLM JEPA, that really gives you the best of both worlds. It keeps the standard generative loss, that next word prediction, which makes sure the model is still awesome at writing natural-sounding text. But then it adds a JEPA loss, which forces the model to predict the abstract idea of the code from the abstract idea of the text, so it's learning to both write and to think more abstractly, all at the same time.
Okay, so the theory sounds great, right? But does it actually make the models better? This is the fun part. Let's look at the numbers and see how LLM JEPA did when it went head-to-head with the old-school training methods.
And wow, the results are pretty clear. On one dataset, the standard Llama 3 model got about 51% accuracy. But with the LLM JEPA training, that number jumped all the way up to over 66%. That is a huge leap in performance, and it's all just from changing how it learns.
And in some cases, the jump was even more wild. Get this. For the OpenLM model on one specific dataset, the accuracy more than doubled. It went from about 12% to over 25%, a 111% improvement. That's the kind of thing that makes everyone in the AI world stop and take notice.
And this wasn't just a one-hit wonder either. The same pattern showed up again and again with amazing consistency across a ton of different tasks, everything from solving math problems to writing database queries. This tells us the benefit is real and general, not just some lucky fluke.
But the improvements here aren't just about getting a higher score on a test. It seems like LLM JEPA fundamentally changes how the models learn, and that leads to AI that's just more robust and more reliable.
So to understand why that is, we need to talk about a super common problem in AI called overfitting. This is what happens when a model doesn't really learn the rules, it just memorizes the answers. It's like it gets an A+ on all the homework, but then totally bombs the final exam because it can't handle any new questions it hasn't seen before.
And this right here is where LLM JEPA is a rock star. It seems to fight overfitting directly.
What the researchers saw was that with standard training, a model's performance often hits a peak and then actually gets worse as it starts to overfit. But the models trained with LLM JEPA, they just kept getting better and better. This is a huge clue that they're learning the real general concepts, not just memorizing the training data. And that is a massive step towards building AI we can actually trust.
So, let's zoom out and wrap this all up. What does an innovation like LLM GPA mean for the future of AI? What's the big picture here?
Now, it's not perfect, at least not yet. The researchers are really upfront about the main drawback. This method is more expensive. Right now, it takes about 3 times as much computing power to train, and that's because the model has to do separate work for each view, for the text and for the code. It's a trade-off for sure, and one they're already working to fix, but it's important to know. But really, this research is a huge first step toward teaching our AI to learn more like we do, through understanding abstract concepts, not just blind memorization. And it leaves us with a really exciting question to think about. If we can build an AI that truly gets the meaning behind our words, what incredible new things will it be able to do next?